So let's do one more word problem, and this one has to do with chemistry. So the pH of a solution can be measured with the formula shown below, where H plus is the concentration of hydrogen ions in the solution. Solutions with a pH less than 7 are acidic, and solutions with a pH greater than 7 are basic. So our first part is, what is the pH of a solution with a hydrogen ion concentration of 10 to the power of negative 4 moles per liter? Is the solution acidic or basic? Alright, so we got this formula, pH equals the negative log of the hydrogen ions. So when I go to do this then, we're looking for pH, and that's going to be equal to our negative log. And we're told we have 10 to the power of negative 4 ions. Okay, from there, I can go and determine what this log is because it's got a base of 10. So that means this log is equal to negative 4. And then negative times a negative is positive. So therefore we get our pH is 4. All right, that's not too bad. Let's look at B then. What is the hydrogen ion concentration of a solution with a pH of 11? Okay, so this time we've got 11 as our pH, and we're going to take the negative log. We're looking for what H is in this case. So we want to know what H plus is. Well, my first thing I can do is multiply both sides by negative 1 to get rid of this negative. So then we're left with log H plus. And from there, I'm going to turn this into a exponential equation. So again, I've got a base of 10. So it'll be 10 to the power of negative 11 equals our hydrogen ion concentration, which is actually what it's looking for. So it's 10 to the power of negative 11. All right, on to C for our last part. So two acids have a pH values of 3 and 6. Calculate the hydrogen ion ratio for the two acids. So what we want to do is actually subtract these because it's a logarithmic scale. So we're going to go 6 minus 3. So that's going to be our left side. And we'll say this is pH 1 minus pH 2. Now on the right side, we're going to go back and use this logarithmic formula we were already using. So for pH 1, it's going to be negative log, and then H plus 1. So that represents our pH 1. And then we're going to subtract negative log H plus 2. And now we can want to simplify this as much as we can. So 6 minus 3 is 3. Here the idea is to combine these two logs. So I'm going to need to turn this minus sign in front of the log into an exponent for. So it's going to become log H plus, or hydrogen ions, and that's all to negative 1. Here this is going to become an addition, plus log H plus 2. The most common thing people will forget is that this is a negative in front of here, and that you do have to move it here before you can combine those logs, or you won't end up with it as a ratio. All right, so we get 3. Now we can use the product law, so we get log, and I'm going to do something right now. This is actually can be rewritten as 1 over H plus 1, so we can reciprocate it. And that'll make my life a little easier because 1 times H plus 2. So we're going to get, so I got to make that a little bit smaller there. So we got H plus 2 all over H plus 1. Okay, so now we have our ratio of our concentration. And so from there, we can turn that into an exponential equation. So we get a base of 10. So 10 to the power of 3 equals H plus 2 all over H plus 1. Which means that this is about 1,000 times more acidic than 3, or 3 is 1,000 times more acidic than 6. Now there are a couple parts I hid from you. The D part is just getting us to derive these two possible formulas. We did that in the previous word problem, so I don't want to do it again. What I do want to do though is this E part. So what is the pH of a solution 1,000 times more acidic than a solution with a pH of 5? Now there is a couple of different ways I could do this. We have two different formulas here that we've been given. We're looking for pH, so we probably want this one. I like having to do the least amount of rearranging as possible. So if I'm looking for a pH, I'm going to make it that one right there, that guy. So I'm looking for pH 2 in our case, and I'll say pH 1 is this 5. It doesn't really matter. These could be flipped because inside of our second half of the equation, you just flip which one is on the numerator or denominator. Okay, so I got negative log. Now, again, I have the 2 first, so the one I'm looking for is in my numerator, and I'm told that it's 1,000 times more acidic, meaning it's going to be 1,000 on my numerator, and this is just relative to each other and compared to 1. It also made this calculation easier as well, because otherwise if I flip these, this would be 1 over 1,000, which isn't the worst thing, but all right, from here then, I can just add 5 to both sides. So I get negative log of 1,000, which you could probably do without even a calculator if you had to. Well, maybe we will. So let's do that just for you. So we get 10 to the power of 3, which means that because this is a base of 10 on the log, this logarithm evaluates to 3, but there's a negative in front, plus 5. So therefore, we have a pH of 2. And hey, you didn't even need a calculator.